So let us see butene. For butene, for butene, butene is C4H8. C4H8, because it must differ by a CH2 group. And what will be our structural formula for butene? Butene is having four carbon atoms. Butene has 4 carbon atoms, and I choose to place my double bond there. So I want to place my double bond between, this is 1, 2, 3, 4. So I choose to place my double bond between carbon 3 and carbon 4. So since my double bond is between carbon 3 and carbon 4, it means that carbon 3 is having 3 bonds, 2 from carbon 4 and 1 from carbon 2. Carbon 4 is having 2 bonds because it is sharing it with carbon 3. Carbon 2 is having 2 bonds. It's getting 1 from carbon 3 and 1 from carbon 1. While carbon 1 is having 1 bond because it is sharing with carbon 2 and it's just only having 1. So how will 8 hydrogen atoms be distributed amongst these 4 carbon atoms? Since carbon 3 is having 3 bonds, it needs only 1 hydrogen. Since carbon 4 is having 2 bonds, it means it needs only 2 more hydrogen. 3 gone, 5 to go. Since carbon 2 is having 2 bonds, it means it needs 2 more hydrogens. 5 gone, 3 to go. Since carbon 1 is having 1 bond, it means it needs 3 more hydrogens, and it takes the remainder 3. And this is how it is done. So the condensed formula will be CH3, CH2, CH, and CH2. This is the condensed formula for butene. So, having seen that, we will now expect the students to attempt to finish up pentene, hexene, heptene, and octene. These are the first 6 members of that homologous. First 7 members, even we have up to octene. So you can finish up pentene, hexene, heptene, and octene. And I think it will be so easy for us to go. So having seen that, let us take a look at the next homologous family, which is alkynes. It is pronounced alkynes. Alkynes. It is pronounced alkynes. Okay, having seen that, alkynes are also unsaturated hydrocarbons with triple bonds between their carbon atoms. The first member is ethyne. So alkynes also do not have a meth. There is nothing like methane in alkynes. So just like alkenes, alkynes also do not have any meth in their family. So the first member is ethyne. Ethyne. Others are propyne, butyne, pentyne, etc. The name of alkynes are derived by replacing the ANE of alkanes with YNE. Replacing the ANE of alkanes with YNE, that is to say, when we replace the ane in alkanes with yne, we have the name for any given alkyne. And alkynes are having general molecular formula of CnH2n minus 2. CnH2n minus 2. Let us take a look at a chart for the alkynes. A chart for the alkynes. So the alkynes are C2H2, C3H4, C4H6. So they don't have a meth in that family. But the first member is eth, ethyne, propyne, butyne, pentyne, hexyne, heptyne, octyne. These are the family members of alkynes and etc. So we are looking at the first 7 members of alkynes. The first 7 members. These are examples. So just like we did for alkenes, let us take a look at the structural and condensed formulae for alkynes. Let us take a look at it. So now we write as we have done. Now taking a look at the alkynes, like we have done in alkenes, now we are looking at alkynes. We are taking a look at the alkynes. The alkynes have a general molecular formula of CnH2n minus 2, where n is greater or equal to 2. So they don't have a 1 in their family. That is to say, n did not begin from 1. N is greater than 1. So n is either greater or equal to 2, from 2 and above. So since it is like that, it means the first member in alkynes is going to be C bracket 2 H into 2 bracket 2 minus 2. So this is going to give us C times 2 is C2, and then our H, here we have 2 times 2 will give us 4. 4 minus 2 gives us 2. So this is the first member of alkynes, and its name is ethyne. Ethyne. The second member of alkyne will be C bracket 3 H 2 bracket 3 minus 2. So this will be C3 H. 2 times 3 is 6. 6 minus 2 is 4. So this gives us the member propyne. Propyne. So having seen that the compound propyne is C3H4. Having seen that the compound propyne is C3H4, I can proceed on and on to give the other members of the alkyne family. Propyne is the second member, and the third member should be butyne. The third member should be butyne. I can choose to use the general molecular formula in deriving the formula for butyne, but all the same, for simplicity, I can also say to myself, if I choose to add C2 CH2, I beg your pardon, if I choose to add CH2 to propyne, it's going to give me my formula for butyne, and that is C4H6. So my butyne is going to be C4H6. It's as simple as that, because each member differs from the other by a CH2. So if I am to look at the fourth member, which is pentyne. For pentyne, and I choose to add CH2 to butyne, pentyne is going to give me C5H8, and it continues on and on. So this is how to generate the molecular formula for any of the members of alkynes. Don't forget that the general molecular formula for alkynes is CnH2n-2. So when you are to manipulate any calculation, we always make use of this formula. Okay, having seen that, students, you can go ahead to get yourself the formula for hexyne, for heptyne, octyne, and etc. So go ahead to get hexyne, heptyne, octyne, and higher alkynes. So this is how to get the molecular formula for the alkyne. Now, having seen how to get the molecular formula, let us proceed to looking at how to get the structural formula and the condensed formula. So we are going to see how to get structural formula and the condensed formula for the alkynes. So what we are going to simply do is to say this is alkyne. So we have our alkynes, and we have the molecular formula, MF, and this is our structural formula, and we have the condensed formula. So let's pick the first one, who is ethyne. We have ethyne, and the formula for ethyne, molecular formula for ethyne is C2H2. So having seen that, what will be the structural formula for ethyne? Ethyne has 2 carbon atoms. Since it has 2 carbon atoms, we have said that alkynes are characterized with the possession of triple bonds between their carbon atoms. That is to say, they are unsaturated hydrocarbons. So it implies that alkyne will have triple bonds between its carbon atom. Now, carbon 1 and carbon 2 have triple bonds, which means our first carbon is having triple bond. Our second carbon is also having 3 bonds. Now, how can we distribute 2 hydrogens between the 2 of them? It is simple. This takes the first hydrogen and this takes the second hydrogen. So each of the carbons are satisfied now with 4 bonds. Carbon 1 has 4 bonds. Carbon 2 also is having 4 bonds. Now, having seen that, this is how to write the structural formula of ethyne, and it is simple. The condensed formula will therefore be this way: CH. That is the condensed formula for ethyne, and it is still the same thing as C2H2. So this is how to write condensed formula and the structural formula. Okay, let's proceed to the second member of the alkyne family, and that is propyne. Propyne is C3H4. Since propyne is C3H4, the structural formula is going to be 3 carbon atoms. Since we have 3 carbon atoms and 4 hydrogen atoms, how are we going to distribute these 4 hydrogen atoms? Like we saw in alkenes, we must place our triple bonds either at the X between the left extreme carbon, which we have designed, which we've designated as carbon 1, or if we are to begin from the right hand side, we may choose to place our triple bonds between carbon 3 and carbon 2. So either way is fine. Now, if we choose to place our triple bond between carbon 2 and carbon 3, it means that carbon 3 is having triple bonds and carbon 2 is also having triple bonds. Then it means we are going to have just one single bond between carbon 1 and carbon 2. So it therefore implies that carbon 1 is having one bond and it needs 3 more bonds. Carbon 2 is having 4 bonds, so it implies that it is not needing any hydrogen. It doesn't need additional bonding with hydrogen because it's already complete. While carbon 4 is having 3 bonds, so it means it needs 1 more hydrogen, since all carbon atoms must have 4 bonds. So it implies that we're going to give carbon 3 1 hydrogen and carbon 1 takes the rest of the hydrogen atoms. And this is how we can draw the structural formula of propane. Don't forget, students, that we have said before that you may choose to place your triple bonds between carbon 1 and carbon 2. Then single bonds will be here. If that is the case, it means that our carbon 3 will now have the 3 hydrogen atoms, and our carbon 1 will have the single hydrogen atom. Either way is correct. So for this, our condensed formula is going to be CH3 CH. And in this case, it is going to be CH CH3. And this is how it's going to be. Either way is still correct. So let us take a look at the third member of the alkyne family. This third member is butane. So we are looking at butane. Butane is having the molecular formula C4H6. And it's going to have a structure like this. 4 carbon atoms. Since it has 4 carbon atoms, we may choose to place our triple bond between carbon 1 and carbon 2, depending on which side we choose to label as our carbon 1 and carbon 2. So having seen that, it implies that our carbon 1, 2, 3, and 4. It means that our carbon 1 and 2 are having triple bonds, and here we must have single bonds. So it means that carbon 1 needs just 1 hydrogen. Carbon 2 doesn't need any hydrogen again because it's already complete with 4 bonds. Carbon 3, we need 2 more hydrogens. And carbon 4 will be needing 3 hydrogens, the extra 3 hydrogens. And that is the structure. So the condensed structure or formula for butane will be CH, CH2, and CH3. So this is the condensed formula for butane. So the students can continue on and on with pentane. You can go ahead to look at pentane, hexane, heptane, octane, etc.